Hi, today we will be conducting Young's double slit experiment to prove that light travels in waves. Firstly, before we start, here are the apparatus that we need. Our light source. In this case, I'll be using a green light laser, a black marker, so that I can color this thin piece of cardboard so that the edges of the slits don't allow light to pass through. And as you can see, I've cut two very small slits because these slits, if they are too big, light will just pass through either one of the slits and the experiment won't be successful. So what's going to happen is I will take my light source, in this case my laser, and I'm going to shine it through these two slits, and an image will form behind there. So I'm shining the light now through the two slits, and you're gonna see this pattern. It's not very clear, but if you look carefully, if I were to use a white light in place of this green light, it will actually be alternating between black and white. So you see those two white spots, those are the bright spots, and in between is one black spot. Here's a clearer picture of the image formed on the screen. Now here is the explanation. My light source, I shine my laser through the double slits, and the image that I showed you just now forms on the screen. Now, light from this light source will travel until it reaches these two slits. Now let's say I'm a light wave, for example. I will either go through the slit on the left or the slit on the right. When these light waves pass through these slits, what happens is that these light waves spread, or in other words, they diffract, and they form a semicircular sort of pattern when we look in terms of the wavefront. Now, there are two types of wave interferences. There is constructive interference and there is destructive interference. Now, when my laser shines through these two slits and then my light waves diffract after passing through these slits, they will eventually meet at the screen over here, correct? Now what happens is, when two light waves are in phase, meaning they are identical in vertical displacement as well as the period, they will undergo constructive interference. And in this case, that forms a bright spot, which was seen in the image that I showed you. And right after that, you'll realize that you will have a consistent pattern of white, black, white, black, white, black. In this case, it will be green, black, since I'm using green light. But the reason for that black is because the adjacent waves to the white spot that meet on the screen undergo destructive interference, which means these two waves are not in phase. They are not identical, and that's why they cancel out each other and they form a black spot. So that is why you have an alternate of green, black, green, black, in this case because I'm using a green light. But if we were to use a white light, you would see a consistent pattern of white, black, white, black. If I were to shine my light source through two slits. Now you might be wondering, how does this prove that light travels in waves. Now, because of the image that was formed on the screen over here, we know that light, after passing through these two slits, was diffracted to form that image on the screen with that green black alternate. And it shows that light travels in waves because if light did not travel in waves and travel in some other form, it would just shine through these slits and you wouldn't have that same image. But because light travels in waves, the light waves were diffracted after exiting these two slits and after undergoing alternate constructive interference. That's how I get my green. And then next would be a black spot, which would mean destructive interference. It shows that wave interference, be it constructive or destructive, occurred because my light was diffracted here and that image was formed here. So this actually proves that concepts of waves were used here. Over here, where it passed through the slits and where it formed on the image. And that's why we can say and we can prove that light travels in waves.